Okay, so this does not tell us. It tells us the number of showing the time it takes a number of students to complete a Buta. It doesn't tell us how many, but we can tell because the top point is right here. And if I go over to the side, that means I'm at 200. So there's a total of 200 students that were told in this computer game. So it says from the graph, find the median time. This is jumping all over the place right now. So the median time means where does 50% happen? So that's 0.5 times 200. That means where does 100 happen? 100 kids happen. All right, so 100 is right here, which means I'm going over and I'm right there, which means that's 25. So the median is 25. The interquartile range, which it asks quite often, means I need 75% minus 25%. Got to figure out where these are. So 0.75 times 200 and 0.25 times 200. This is 50, so I need to look and see where 50 happens, and that's 150. So I go back to my graph, and I go with 50, which is, let's see, 45, 50, 55, 60, that's not right. So, hang on, there's 1, 2, 3, 4, 5. Okay, so go by 4. So 44, 48. So 50 is right in the middle of those two. So 50 is right about here. Which if I go down there, these are by 1, right? 16, 17, 18, 19, 20. So that's 15, 16, 17, 18. And you really got to be careful here. You can zoom in. But this is 18. And then we're going to see where 75% happened, which is at 150. And 150 is in between those two. So I'm coming over here, and it's right about there. I have that lined up right, which comes down to 32 if you look carefully. That's 32. So 32 minus 18, 14 is the interquartile range. Now, I could use that to find outliers if I needed to, just like we did last year. Now, this is challenging right here, too, because this wants to know how many lie between these different points. And basically, you're finding the difference between these two. So this wants to know from 15 to 20 in minutes, how many people lie between there. All right, so 15, and hopefully when you do these, they're at reasonable numbers. So 15 starts at 40. 20 looks like it's about 62. So 62 to 20 is 22. So let's see here. So P looks like it's about 22. And then Q looks like from 35 to 50. So 35 to 50. Jump all over the place here. So 35 is 160, and 50 is right there. So 150 to 192. So 92 to 150 is 42. So 150 to 192. That's 42. All right. Now that total should add up to 200, so I can see if I'm right, and I'm definitely not. So it's not going to add up to 200. It's probably supposed to be even though. So let's see. Let's add these. Let's add up what's there. So 20, 20, 40, 60, 10. So 20 plus 20 plus 40 plus 60 plus 10 is 150. All right. So it's a total of 150 accounted for, which means there's 50 left, which means it cannot be 22 and 42 because that's 64. All right. So let's see if I did something else. Go back. 15 and 20. So 15 is at 40. 20 is at a little bit more than 60, but if I said it's 60, I can say it's 20. So we'll say this is 40 to 60, and we'll say that that's 20. And then we'll see. That should make this right here 30. But let's see what I did wrong. So 35 to 50, I must have done something wrong. So 35 and 50. $35 is definitely that. And 50 is this guy right here, which is up to there. So I don't think they have the other numbers right. I'm gonna leave that at 42. I'm gonna look back at this, and if it's wrong, I'll come back and I'll fix it. But that's what we've got there. Calculate the estimate of the mean time it takes to finish the computer game. I'm gonna cross that one off because that one is only going to do with this particular unit or this particular section. What percent of the student have a time of 45 minutes or less? So I'm gonna go to 45 minutes. 45 minutes. I'm going to go up and find out where that is. So 45 minutes goes up and hits right here. And then if I go over for that one, it's right here. And these go by 4, and I can figure that out by dividing out what it is. So 184. So 184 are at that point or less. So to get the percent, it's 184 divided by 200 to get the percent. So 184 divided by 200. 92%.